So we'll look at sampling methods. Yesterday we did an activity in class where we actually took some samples different ways out of that population of jelly blubbers. So we can see there's many different types of sampling, and some have their advantages, some have their disadvantages. It kind of depends upon what we want to do. So the main goal that we always want to keep in mind is we want to get best possible sample. So here's the basic idea behind statistics. We have some population, okay, and we're interested, something's going on with that population, but if say the population of the US, it's really hard to get that many people. So what we'll do is we'll go ahead and we'll take a sample of that population, and based on that sample, we'll come up with some statistics, X bar. Um, we can come up with standard deviation, right? So we've come up with these statistics, and there's other statistics. Those are the two most popular, but median is a statistic. Mode, not used that much. We can come up with range. There's all these different statistics, basically just numerical representations of the group. So we started with this population. We came over here, took a sample of it. We did some math with the sample to get statistics. And then from there, we can move over, and these are what are called parameters. And those parameters can then be used to describe the population. We've talked about this before. The trick here is this arrow right here. As we go from population to sample, how we take a sample is important. So that's where we're at. If people take bad samples, then we don't really think that they've done good research. We don't think that they've done a good job with what they're trying to tell us. And that's where most statistics, in terms of people that are doing observational studies or even experiments, that's where a lot of people get kind of picked apart, is because they don't have good sampling techniques. So the simplest type of sample is a simple random sample where everybody in the population has an equal chance of being chosen. So what you'll do is take a look at what we're trying to do, create a sampling frame. Each individual in the frame gets a number, and we start selecting random numbers until we find however many people we want. So an example, say there are 80 students enrolled in this STAT course. There's about 80 here, and we want to select a sample of 5. So just go through the sampling frame. Here we want to we need the roster of all the students enrolled, and each student will get a number from 1 to 80. From there, we'll use some kind of random number generator to choose the first 5 students that we come across. One of the big things here, we're going to ignore numbers not on the list and repeats. So we want unique numbers, right? We want unique individuals. We're not going to ask the same person twice. So, 2 ways to be random. One that we're fully aware of, the random number generator. Under the math, over in the probability menu, is a random integer function. And so there's one way we could get our 5 individuals, random integer, 1 comma 80. So it's going to pick between 1 and 80. And then you don't have to have that 5. We don't have to have it, but that'll just pick 5 numbers at a time. We might have repeats, so we want to ignore repeats until we get our 5 unique values. Another way that we haven't seen yet in class, but a lot of times people will use these, you'll see random number tables. And it's basically just a list of a bunch of numbers. So what you'll do is you'll start in a row and work your way through to make your selections. One thing you have to be aware of, and you'll see it in this example we're about to do, if you have double digits, so you see our example below, 45 people have been assigned a number. So if you look at that example with the 45 people, well, if we put them, these 45 people on the roster, let's say Joe is first, Sally is second. Joe's not going to be assigned the number just 1. He's going to be assigned the number 0, 1, 0, 2. That way, we go through. So that's what you have to be careful if you have a bigger sample that you're taking. And also be aware we might have to skip numbers. So let's look at this example. 45 people have been assigned this number. We want to randomly select 6 of them. So start working left to right. The first person we're going to pick, right? We're going to pick person 41. So we get number 41. There's our first selection. The next number is 47. Well, nobody was assigned 47, so we're going to skip it. The next number, there's going to be spaces in this, and that's honestly, that's just so it's a little bit easier to read the table. So the next person we're going to go to is 61. So there was no 47, so we skip it. There's no person numbered 61, so we skip it. But we still have to consider those values. The next one's 27. We should have someone with number 27, so we got that. 38, there should be a number 38. 48's next. We don't have a 48th person, so skip it. 34. Number 34 will be selected, so we're up to 1, 2, 3, 4 people. 75. Oh, nobody numbered 75. And then 04. So that's whoever's fourth on the list. So we're up to 1, 2, 3, 4, 5. We need one more. 88 will skip. 82 will skip. 63 will skip. 51 will skip. And then finally, so we skipped a few until we got to our sixth acceptable value for us, which was 20. So if we'd have kept going, you see, we could get some more numbers as well. But that's how the random number table works. We just start, work your way left to right, and you'll get your random sample that way. So between random integers, and there'll be times where you might be asked to use a random number table. That's how it works. So another type of sampling is stratified random sampling. So basically what you would do is maybe you'd separate your population into these homogeneous groups. So we divide things into strata, right? They're groups. And then we do a random sample within each strata and then combine the results. So say we want the freshman opinion on cafeteria food on campus, but maybe guys and girls have different opinions, strangely enough, right? Women and men, different opinions. So what we would do is we'd go ahead and get all the enrolled students, but what we'd want to do, and I guess really this shouldn't be students, it's all enrolled freshmen. We don't really care about the upperclassmen. That would be another way that we could separate this maybe. Freshmen have different opinions than seniors, but for this example we're going males, females. So we'll take all of the freshmen and then we'll separate it. One male list, one females. And then we would, then assign numbers within. So our males on one side, and then our females on the other. So, Joe will get a 1, Sam will get 02, and then over here, Rhonda will get 01 for the females, and Sally will get 02 for the females, so on and so forth. And then you'll do a random sample for males, repeat that for females, and then we could determine an opinion for both of them. Maybe they're similar, maybe they're not. That'd be a whole different study we could do comparing the two. Another way we could collect samples is clusters. So basically we feel like we've got a good representative group of the population. So we select one or multiple clusters at random and perform basically you would, the census, this is a familiar word to us. That's where we ask everyone in the group. So we'd have to actually get once we have our cluster, we're going to have to get everybody in the group. This is kind of like yesterday when we did we threw out the net. You measured everything that was within that one net. That was kind of like doing a cluster sample. So maybe freshman opinion on food, maybe gender, we're not going to let it be an issue. So what we can do, just walking around campus thinking, well, there's a big mix of freshmen, sophomores, juniors, seniors. How are we going to figure out which one's which? Most of the freshmen are going to live in dorms, so we could use dorms as a cluster, right? And then we'd randomly choose one or two dorms and ask everyone in the dorm their opinion. So that's another way, right? So the cluster here, right? The dorm would be the cluster, right? So the dorm would be the cluster. And then we'd have to make sure that we try to get everybody in the dorm to get their opinion. So, you could also multi-stage. So basically you just combine a few different methods. So maybe opinion on cafeteria food. Maybe we do want to go back to gender, right? We're going back and forth. So we go to the dorms as we talked about. But what a lot of dorms will do is males will be on one floor, females on another. So we've randomly chosen our dorm. There's our cluster, and then we kind of go and we randomly choose the floors with men on one floor, and then we randomly choose a women's floor, and then we'll go and we'll interview that entire floor. So the idea of randomness is here, right? We'll randomly choose which dorm, and then we'll randomly choose which floor, right? So the idea of randomness, even though we're kind of changing our sampling method, the idea of randomness is still there, which is very, very important. So another type, systematic sampling. So we did this one yesterday where we, I think, found the length of every seventh jelly blubber, but maybe we were going to do a study here at the school, and we sit at the front door and we ask every 10th person to walk through the door. So our sampling frame would be we're going to, wait and catch every 10th person until we get um, our, 30-person sample or 40-person sample. The idea of randomness is still here, though. Somehow the way we're going to start is going to have to be random. Yesterday I kind of did it. You just picked a number from 1 to 10. And then from there, it becomes very systematic. And so you just have to select what's your number. Every 10th person, 12th person, every 15th individual, whatever it might be. This is probably the cheapest and easiest because you don't have to, you know, get a list of everybody involved. You just sit there and you go. Um, and there shouldn't be any kind of association. You're not going to have to worry about repeats because every fifth or 10th individual is a little bit different. Last type of sample is convenience sample. You just find those that are easy to ask. Um, Maybe I wanted to find some kind of policy that we're after at school, so I just asked the class, could you guys are convenient to me? This is probably the worst possible way to sample people.